systemic destruction of science. That is how one unnamed scientist from the National Oceanic and Atmospheric Administration described the shocking new policy that threatens to leave hurricane experts in the dark just as some of the most powerful storms on Earth begin to brew. At first glance, this move seems almost unthinkable. Why would a crucial stream of data, used for decades to predict and track hurricanes and other severe weather events, suddenly be cut off? And how could this decision, seemingly made behind thick layers of bureaucracy, impact the safety of coastal communities from one side of the ocean to the other? Today, we are going to dig below the surface of these urgent questions. Yes, you heard it right. From how a monumental shift in control over satellite information can blindside meteorologists to whether it might pose an existential threat to thousands living in hurricane-prone regions. In this in-depth exploration, we will unmask the core of the controversy, reveal the agencies embroiled in this swirling storm of decisions, and see if there is any hidden motive behind the sudden clampdown on publicly shared data. We will also uncover the profound scientific, economic, and humanitarian implications of losing easy access to these vital readings from orbit. In this story, prepare to discover exactly why the coming hurricane season itself sparked a wave of unease among federal scientists and private forecasters alike, how the Defense Department found itself at the center of a swirling debate on cybersecurity, and whether the National Oceanic and Atmospheric Administration has the capacity to fill the gap on its own. We will expose the role of the Navy's Fleet Numerical Meteorology and Oceanography Center, along with the Defense Meteorological Satellite Program, and peel back the layers of conflict fueling the tension among agencies that usually collaborate in the name of public safety. By the time we reach the end of this eye-opening account, we hope to provide clarity on how it all connects to the urgent reality of storms that can grow from mild disturbances to raging monsters in a matter of hours. So, brace yourselves. We are about to enter a realm where the slightest glitch in gathered meteorological data can mean the difference between a coastal city's timely evacuation and a disastrous scramble in the dark of night. First, let us bring you the broad strokes. The United States Department of Defense oversees certain satellite programs that have become crucial for meteorological data gathering. For roughly 4 decades, these Defense Meteorological Satellite Program satellites have quietly gathered everything from visible light images to infrared and microwave readings of Earth's atmosphere, providing persistent coverage that is vital for storm prediction and tracking. 3 satellites remain operational in orbit, silently circling our planet and capturing data for experts on the ground. Now, with the arrival of the official Atlantic hurricane season, running from June 1 to November 30th, and the parallel development of formidable storms in the Pacific, meteorologists have consistently relied on these satellites to analyze wind speeds, cloud formations, temperature fluctuations, and even changes in storm eye walls. Any break in this data supply can hamper efforts to forecast and respond to hurricanes in real time. Traditionally, raw readings collected by the Defense Meteorological Satellite Program were passed along to the United States Navy's Fleet Numerical Meteorology and Oceanography Center for processing, before distribution to civilian science agencies, including the National Oceanic and Atmospheric Administration. The data pipeline formed a seamless chain from orbit to practical application, fueling forecast improvements and data-driven guidance to emergency planners. But, in a surprising twist, the Defense Department decreed that this flow would end. By the close of June in 2025, ingest, processing, and distribution of data from the Defense Meteorological Satellite Program will be permanently discontinued, at least as far as scientists outside of the Department of Defense are concerned. The official explanation? According to statements, it is a matter of cybersecurity. As reported by individuals such as Mark Serez, director of the National Snow and Ice Data Center, there is an insistence that rising concerns over cybersecurity vulnerabilities are behind the shift. Other participants in the meteorological community have pointed to government budget concerns and broader efforts to realign resources. This unconventional move has left many meteorologists stunned. As of now, forecasters agree that these microwave readings, in particular, have been critical to deciphering what happens within the tall towers of a hurricane's cloud cover. Hurricanes often develop rapidly overnight, going through something called rapid intensification, which can escalate their power with frightening speed. Microwaves at certain wavelengths can penetrate cloud canopies, giving scientists an inside look that visible or even infrared images might fail to provide. For meteorologists, removing or limiting this vantage point is akin to losing a prized pair of binoculars on a dark night. According to Kim Wood, an atmospheric scientist from the University of Arizona, knowledge gleaned from microwave imagery is essential for discerning the metamorphosis of these storms in ways that purely visual satellite imagery cannot. Right now, meteorologists can see if the eye wall is forming anew or if the center of circulation is shifting, both of which can alter the likely path of a storm. So, why would anyone choose to shut off this data pipeline at a time when climate scientists warn that storms in tropical basins might be growing stronger and forming with greater unpredictability? Before we dive further into that question, here is a small yet heartfelt request. If you find this revelation about losing a key source of storm data alarming, please consider giving a friendly tap on that like button to let others know about the seriousness of the situation. This story is about more than just satellites. It is about how we protect ourselves, our families, and our neighbors when nature decides to unleash its fury. Around the United States, the urgent question remains: do we have enough backup systems to fill the void? Indeed, the National Oceanic and Atmospheric Administration, along with the National Aeronautics and Space Administration, also operates advanced weather satellites. NOAA's geostationary operational environmental satellites, often referred to as GOES, and NASA's Earth Observing System satellites, among others, cover large swaths of Earth's surface. They produce dynamic imagery at various wavelengths and can capture storms from far above the equator. NOAA spokespeople have publicly insisted that they possess a complete suite of cutting-edge data and models that will ensure the gold standard weather forecasting the American people deserve. This official stance, reiterated by NOAA Communications Director Kim Doster, communicates confidence. Still, among many leading hurricane experts and oceanographers, confidence is overshadowed by a gnawing worry. These are professionals who have come to rely on the synergy of multiple data streams, public, private, civilian, and military, to piece together the mosaic of our atmospheric conditions. In the Atlantic alone, one mistake about a tropical storm's trajectory could risk thousands of lives and cause billions of dollars in economic damage. Brian Tang, a hurricane researcher at the University at Albany, expressed surprise that such a crucial data source would be taken off the table, especially because the technology behind these satellites has historically worked hand in hand with NOAA's other instruments. At the root of the dispute is speculation that the defense satellites and instruments remain fully operational, but the Department of Defense is withdrawing a portion of the data feed for broader security reasons. As the United States Space Force, which also manages certain satellites, pointed out, the Department of Defense still sees the satellite data as important for military operations worldwide, including for the safe navigation of naval ships. Yet the rest of the meteorological community will suffer a blackout. Publicly, the Pentagon has not elaborated on the specifics, citing issues of national security, but it is understood that officials believe open sharing of raw readings might leave their systems vulnerable to cyber intrusions. Some meteorologists wonder whether the real story lies in funding cuts or a desire to modernize the entire platform, funneling resources into newer models of high-tech observation satellites. Others suspect continuing battles over departmental jurisdiction, who truly owns which data, might have finally reached a tipping point. Meanwhile, NOAA itself faces budget and staffing constraints. This combination might be creating a perfect storm of reduced coverage at exactly the wrong juncture. One NOAA scientist vented frustration in an interview with The Guardian, decrying the move as part of a broader pattern of scientific marginalization. Is that a fair assessment? The Defense Department's official stance says the impetus is purely pragmatic. They claim the distribution chain would remain open indefinitely if not for potential vulnerabilities in the systems relaying data from the satellites to outside entities. While many details remain inaccessible to the public, such concerns are not new when it comes to government cybersecurity. Even the slightest infiltration into a satellite feed could, in theory, compromise national security or open backdoors into sensitive defense systems. But let us consider the very real impact on hurricane forecasting. Allison Wing, a hurricane researcher at Florida State University, exclaimed that in some sense, experts may become partly blind. She stressed that in earlier eras, particularly before satellites capable of microwave imaging soared into orbit, hurricane tracking had so many blank spots that a storm could erupt overnight into a far stronger system, surprising forecasters at daybreak. Cuts to any part of the observational chain risk bringing back that era of unpleasant surprises. Additionally, the Fleet Numerical Meteorology and Oceanography Center overwatches sea ice patterns in the polar regions. Losing that data source to a potential firewall behind the Department of Defense significantly impacts climate science as well. From an environmental perspective, with ice conditions shifting at an accelerated rate in the Arctic, the continuous flow of near real-time coverage from these satellites is indispensable. It informs shipping routes, environmental monitoring, and crucial ecological research, bridging the gap between theoretical modeling of climate change and actual observed shifts in Earth's polar domains. If the story ended there, it would be alarming enough, but let us explore deeper. The National Hurricane Center has stated it does not expect less accurate forecasts overall, pointing to NOAA's data sources as a robust backbone. And historically, NOAA satellites have done a commendable job capturing major storm patterns. Yet, the lack of synergy with the Defense Department means certain advanced metrics, like those microwave glimpses, could be more sporadic or delayed. When a storm is galloping toward land, hours matter. The difference can be measured not just in property damage, but in human lives. Critics ask, if the Defense Department truly wishes to safeguard data channels from cyber threats, is there no compromise that preserves the vital streams for meteorological analysis? Could partition networks be established, or could the data be partially anonymized or delayed to mitigate risk while still preserving the functionality for forecasters? So far, publicly available statements offer no such alternative. NOAA experts appear reluctant to comment on behind-the-scenes negotiations, presumably because those negotiations, if they took place, may have led nowhere. Let us pivot for a moment to the big question. Does it matter that the National Aeronautics and Space Administration runs other satellite constellations? NASA's Earth Observing System includes satellites such as Terra, Aqua, and others that are loaded with instruments to study various aspects of the Earth's environment. Meanwhile, NOAA's GOES satellites, perched in geostationary orbits, watch storms with a vantage from more than 20,000 miles above Earth's surface. These satellites excel at capturing broad imagery in visible and infrared wavelengths. But there are niches in the microwave spectrum, something the Defense Meteorological Satellite Program specialized in, that are not fully replicated by NASA or NOAA. There is also the prospect that future data gaps might arise if older satellites fail. Satellites typically have a finite operational lifespan, and the Defense Meteorological Satellite Program, spanning decades, may not have a direct replacement if budgetary storms swirl further. The underlying theme emerges that an era of multi-layered, cross-agency collaboration in meteorology might be coming to an end, replaced by stovepipes that channel data purely for select government usage, unless advocates can demonstrate that the security risk is manageable. One particularly vivid example, mentioned by storm watchers, is Hurricane Eric, which formed in the Pacific earlier in this month. Using microwave data from defense satellites, meteorologists pinpointed when a new eye wall was forming, an event that often signals the intensification of a storm. Having that kind of precision can allow meteorologists to adjust warnings and keep shipping lanes or coastal communities alerted, drastically mitigating potential casualties. Remove that data feed, and one might see an uptick in the margin of error, or at least a slower response to real-time changes inside a swirling mass of clouds. All this raises the question of accountability. Should the American public, or the international community, for that matter, have a say when data that has been freely shared for decades is suddenly restricted? Many storms do not respect national boundaries. Hurricanes spin across entire regions, hitting multiple nations. In this sense, it is not just the United States that may be impacted by the reduced flow of satellite information. Global meteorological agencies often pool their data, forming a collaborative safety net. If a key tapestry thread is pulled, could the entire pattern unravel? The official notice from NOAA states that the end to ingest, processing, and distribution of the data will arrive no later than the close of June in 2025. This might allow a bit of lead time for meteorological agencies to adjust or find workarounds, but cynics note that serious advanced planning is needed to replace such a robust supply of raw satellite intelligence. Some private forecasters might try forging connections with other agencies or turning to any data still publicly or privately offered from various commercial satellites. Others might hope that NASA or NOAA can ramp up specialized instrumentation that mirrors the capabilities of the Defense Meteorological Satellite Program. At the heart of it all, there remains a fear expressed by voices like Allison Wing and Brian Tang that we could be unprepared for a worst-case scenario in the near future. Hurricanes are often unstoppable forces of nature, made more dangerous by how quickly they can mutate in strength. For the last 4 decades, the Defense Department's vantage from space has been an integral piece of the puzzle, even if overshadowed by bigger names like GOES or NASA. Now that vantage is about to vanish for the civilian community, leaving experts scrambling. It is underscored by an ongoing spree of budget shortfalls at NOAA. The agency, which oversees the National Hurricane Center among many other tasks, is grappling with staffing issues. As the climate crisis demands more resources for research on extreme weather events, NOAA is, ironically, finding itself strapped. Meanwhile, the science community frowns upon any measure that might hamper collaboration and data sharing, especially when it pertains to environmental threats that can cost billions of dollars. Hurricane after hurricane has revealed the costs of underestimating nature's fury, from battered communities to battered budgets. Let us circle back to the staggering phrase that started our journey: a systemic destruction of science. Is that an overstatement? Perhaps not entirely, if we consider how integrated these datasets have become in routine meteorological workflows. One could argue that government agencies must adapt to a modern age of cybersecurity dangers, but critics counter that there is a difference between making data more secure and pulling the plug altogether. And here is a friendly question: how do you feel about all this? If this deep dive into hidden tides and behind-the-scenes decisions resonated, consider sharing this story with a friend, or subscribe so you can tune in for future explorations of how weather, technology, and policy collide. That small action helps ensure more people remain informed, especially those living in vulnerable coastal zones. Ultimately, the world of meteorology is about perceiving hidden patterns. To predict the future path of a monster storm, scientists need the most comprehensive vantage possible, stacking satellites, ocean buoys, surface radars, aircraft reconnaissance, and supercomputers into a single, cohesive system of analysis. Disturb that chain at a critical link, and it can produce ripple effects that go far beyond the immediate circles of weather stations and labs. The ripple might travel to big industries, shipping corporations, municipalities, and families just trying to plan for the next season. It is perhaps telling that NASA's vantage from orbit, NOAA's geostationary networks, and smaller commercial data sources cannot fully replicate the Defense Department's specialized satellite features. The alleged cybersecurity vulnerabilities might be real, but many scientists are left asking whether the cure is worse than the disease. If the Department of Defense continues to gather the data for its own use, might there be a safe alternative pipeline that the country, and indeed the international community, could access? Some insiders speak of behind-the-scenes negotiations that may be ongoing, though no concrete details have leaked. If, by chance, enough pushback arises from scientists, environmental groups, and public safety advocates, it could shape the final policy. Possibly, the door to a compromise is not entirely sealed, but for now, the official line from the Defense Department is that all distribution will cease permanently by the end of June in 2025. Meanwhile, the storms do not wait. Already, the Eastern Pacific has seen named systems swirling, including storms that tested the boundaries of meteorological knowledge. In the Atlantic, experts recall times in the past when forecasters only had glimpses of what was happening in open waters. Without these key satellites, coverage of some brewing tropical waves might be incomplete. That scenario conjures images of residents along the coasts, watching updates that might not capture the full story of a forming hurricane. It also introduces the possibility that forecasts might slightly lag behind dangerous developments, causing potential underestimation of a storm's severity. In short, we are on the cusp of a new era in hurricane tracking, one that might well be less certain, unless alternative solutions are found. As we weigh the immediate cybersecurity concerns against the near-sacred mission of public safety, the swirling tension continues to evoke more questions than answers. However, what we do know is that the next time a monstrous swirl of thunderstorms crystallizes into a named storm, we might not have all the eyes in the sky that we once did. The question is, Can we maintain the same standard of forecast accuracy, readiness, and protective response that we have come to expect? For the countless coastal populations, both in the United States and beyond, this is not just an academic puzzle. It is a matter of life and death, an intersection of policy, technology, and meteorology that demands urgent answers. Once access to DMSP data is gone, NOAA's existing satellites, NASA's Earth observing system, and the handful of privately operated satellites will continue working, but the synergy so carefully cultivated over 4 decades might erode. The next major tropical event could well test those new boundaries in ways that have real, tangible consequences. Our story ends, for now, with more than a tinge of uncertainty. Hurricane forecasters are gearing up, as they do every year, for a season that will last until late autumn. They have spent decades fine-tuning their models, preparing the public, and working intensively with data streams from all corners. Now, with the promise of a hotly contested shift in that data infrastructure, they must adapt all over again. Specialists like Allison Wing caution against ignoring the potential pitfalls of stepping backward in observational coverage. Rapid intensification of a hurricane remains one of the trickiest phenomena to forecast accurately. Without these key microwaves that peek inside swirling storms, how soon might we spot that we are dealing with a monstrous Category 4 or Category 5 beast? The next few years could be the turning point that defines modern forecasting, bridging the line between new technologies and the uncomfortable possibility of data fragmentation. On the bright side, adversity often spurs inventive solutions. Perhaps NOAA and NASA will bolster their satellites with advanced sensors. Perhaps international partnerships will fill the gap. Yet the fact remains that a keystone resource, the Defense Meteorological Satellite Program feed, might be gone soon. As we watch the horizon for the next swirling menace to form, the aftermath of these decisions is sure to be felt in forecast centers, boardrooms, and living rooms alike. For some, it might feel like stepping back to an era when we had fewer instruments on our side. For others, it is a call to innovate. Regardless, the drama encapsulates how technology, policy, and the sheer force of nature can fuse into a single story of global implications. Even though we must wrap up here, do not forget, hurricanes will inevitably come, whether we are ready or not. Let us keep asking questions and illuminating the behind-the-scenes processes that shape how we prepare for these storms. After all, if we learn to unify the pursuit of national security with the pursuit of meteorological knowledge, we might find a compromise that keeps us safer as a society. Until then, stay watchful, stay curious, and remember that knowledge remains the most important safeguard we have against the unpredictability of nature.